So, hello to everyone. My name is Siddharth Srivastava. My registration number is 21BCE5807. And in the previous videos, we talked about Nand2Tetris and its basics. How we can implement basic gates using Nand2Tetris. So, this is the second part of it. So, here we will the second Nand2Tetris project focuses on combining logic gates to create different circuits such as half adder, full adder. We can also create different version of adders such as 16-bit adder, 16-bit incrementer, and we will also see the basic ALU with some of the simple operations in it. So let's move further. First, let us study about half adder. Half adder is a digital logic circuit that performs binary addition of two single-bit binary numbers. It has two inputs, A and B. So here is the, like we can see in the picture, A and B, these are the two input lines, and two outputs, sum and carry. The sum output is the least significant bit, which is also called LSB, and while carry output is the most significant bit, MSB of the result, indicating whether there was a carryover from the addition of the two inputs. The half adder can be implemented using basic gates such as XOR and AND gates. So, like here we have in the diagram, we can see it is the XOR gate and this is the AND gate. So, using these two gates, we have implemented the half adder. So, and here it is the truth table also. So, sum is 0, 1, and here it is 1, and then 0, and carries, there is no carry in the above 3, and the last line there is the carry. So now let's move further. So here is the full adder now. So full adder is the adder that adds 3 inputs and produces 2 outputs. Okay, so the first 2 inputs are A and B, and the third the third input is an input carry as C in. The output carry is designated as C out, and the normal output is designated as S, which is sum. So here in the diagram, we can see like this is the conceptual diagram. So A, B, and C in are the 3 inputs, while in the full adder, we are getting sum and C out as the output. A full adder logic is designated in such a manner that can take 8 inputs together to create a byte-wide adder and cascade the carry bit from one adder to another. We use a full adder because when a carry in bit is available, another 1-bit adder must be used. Since a 1-bit half adder does not take a carry in bit, a 1-bit full adder adds 3 operands and generates 2-bit results, as we have seen in the diagram. So let's move further. Here and truth table is also given here. We can refer here. So let's move further. So here it is. Now we move to 16-bit adder. 16-bit adder, the previous adders adds only single bits, but in today's real world applications, we usually add multi-bit data. So we will need an improved version of previous adders. So it is 16-bit adder, it is the improved version. So 16-bit adder is a good example of it. 16-bit adders take 16-bit data inputs together and also add them together. We can also do addition with numbers having less than 16 bits as well. So here it is the schematic diagram of the 16-bit adder. So now let's move further. So here is the 16-bit incrementer. It is useful to have a 16-bit incrementer chip. So its basic functionality is to increment the value of data by 1. We will see how it works when we will simulate it. And let's move further now. So now we have ALU. ALU, it stands for Arithmetic and Logic Unit. And ALU conducts arithmetic and logical operations, as we know. So it is a major component of the CPU in a computer system. An integer unit is just an integrated circuit within a GPU that performs the last calculations in the processor. It can execute all arithmetic and logical operations like we see on the previous project, like XOR, OR, and NOT operations. So binary numbers can also perform bitwise and mathematical operations. AU and LU are two types of arithmetic logic units. The ALU's operands and code instruct it on which operations to perform based on the incoming data. When the ALU has finished processing the data, it sends the result to the computer memory. So this was about ALU, and here we can see the basic uh, diagram of the ALU. So here it is, step 1 is the fetch instruction from memory, and step 2 is decode instructions into commands, and step 3 is execute commands, and step 4 is store the results into memory. So this is the machine cycle, and ALU plays an important role in it. So now we will move to the simulation part. So it is the hardware simulator. So now we will implement these 5 functions which you have studied using this Nand2Tetris and hardware simulator. So first I'm loading this adder 16 HDL file. I will move the speed to fast, and then I will load script also. TST I have to add. So here I'm running it. So it has run successfully. It has reached the end of the code. So now we will see its output. So here it is the output, and let's compare it. So we have compared also. So both values are coming same. So it confirms that our data is correct. You can see the HDL code here also, and this is the carry pins value. So now we will implement ALU. So here I am loading the chip, and here is ALU TST file, and so I am running it now. So it has reached the end of the program. So it has run successfully, and now we will see the output. So here is the output we can see here. And now we will compare it. So there are no changes in output and comparison. So it also confirms that it is correct. Now we will do full adder. Select the full adder file here, and full adder TST we will do. So let's run it. So it has reached the end of the code. It has run successfully. Now we will see the output. So output is this. As we can see the truth table here. And now we will compare it. So there are no changes in compare values. So that means it is correct. And now we will do half adder. So here it is half adder, and here we are loading TST file. And now let's run it. So it has reached the end of the code. Now we will see the output. Here is the truth table value, and let's check whether it is correct or not. So no changes in the value, so it means it is correct. Now let's do the incremental 16-bit value. So here also I will load. Okay, so let's run. So we have reached the end of the code here. So now I will, we will see the output. So here it is input and here is output. This is according to the values, and we will compare. So we have checked also this is correct. So that means we have run this successfully. So this is how we have run all our programs successfully. So this is the end of the project. So thank you for everyone for viewing my project, and we will come with other videos also regarding Nand2Tetris. Thank you.